In this video, I'm going to cover how to prove or verify trigonometric identities. We will use the Pythagorean, quotient, and reciprocal identities throughout these proofs, so it's important to take note of them. Next, I'm going to cover some of the things to look out for when you are proving trigonometric identities. Here are some tools or steps we will use. Sometimes we will want to change one side of the equation into all cosines and sines. So if we have a tangent, we will change it to sine over cosine. We will also look to see if we can use our Pythagorean identities. For instance, we might have a trig function squared, such as cotangent squared theta, or we might have an expression like 1 minus sine squared theta. Oftentimes, we will also need to rewrite one fraction into two fractions or two fractions into one fraction. We should always check both sides of the equations to see if the number of terms match. If we have two terms on one side and one on the other, that's a clue that we will probably need to combine fractions. Of course, we should always be on the lookout for using our quotient identities, so sine theta over cosine theta or cosine theta over sine theta, as well as all of our reciprocal identities. And the one that students often have trouble with is number 5 here, multiplying by a conjugate. So what happens is we might have something like 1 over 1 minus cosine theta, and this is kind of a clue that if we multiply by the conjugate of 1 minus cosine theta, which is 1 plus cosine theta, over itself, in the denominator we would get 1 minus cosine squared theta, and that's one of our Pythagorean identities. In this first problem, we're going to verify that cosecant theta minus cosine theta times cotangent theta equals sine theta. Since the left side of this equation is more complicated than the right side, I'm going to start by simplifying the left side. First, I'm going to convert to all cosines and sines. Cosecant is 1 over sine theta minus cosine theta. Then I'm going to convert cotangent theta to cosine theta divided by sine theta. And I will just bring down the right-hand side. We're going to keep working the left side until it matches the right side. I need to multiply before we perform the subtraction. Cosine theta times cosine theta is cosine squared theta, and 1 times sine theta is sine theta. We see now that we have a common denominator on the left side, so we can combine these two fractions into one fraction. 1 minus cosine squared theta all over sine theta. If we recall that cosine squared theta plus sine squared theta equals 1, if we subtract cosine squared theta from both sides, we will get sine squared theta equals 1 minus cosine squared theta. I can substitute sine squared theta for 1 minus cosine squared theta, and then we will be able to cancel one of these sine thetas. So one of them at the top will cancel with the one at the bottom, leaving us sine theta equals sine theta. And we have verified this identity. For the second problem, I'm going to verify that cosine theta times cosecant theta equals cotangent theta. For the first step, I'm going to rewrite cosecant as 1 over sine theta. Next, I'll put a 1 under cosine theta and multiply the left side to get cosine theta over sine theta. And that actually equals cotangent theta, and therefore this one's already proven. For this third problem, we're going to verify that cotangent theta times cosine theta equals cosecant theta minus sine theta. For the first step, I'm going to convert cotangent to cosine theta over sine theta. And we can just bring down the right side. Next, I will place a 1 under cosine theta and multiply the left side together. Cosine theta times cosine theta is cosine squared theta, and sine theta times 1 is sine theta. And again, we'll just continue to bring down the right side. We can rewrite cosine squared as 1 minus sine squared theta all over sine theta. Next, we will break it into two fractions, placing the 1 over sine theta and the sine squared theta over sine theta. This brings us to the last step, since 1 over sine theta is cosecant theta, and sine squared theta over sine theta simplifies to sine theta. This identity has been verified. Problem 4 involves a little bit different step. We need to verify that sine squared x divided by 1 minus cosine x equals 1 plus cosine x. Feel free to pause the video and try this one on your own. Because sine squared x plus cosine squared x equals 1 by the Pythagorean identity, if we subtract cosine squared x from both sides, sine squared x equals 1 minus cosine squared x. So we'll make this substitution for the numerator. 1 minus cosine squared x over 1 minus cosine x equals the right-hand side. Next, we will actually need to factor the numerator. 1 minus cosine squared x is the difference of two perfect squares of 1 and cosine x. So this can factor as 1 plus cosine x times 1 minus cosine x. 1 plus cosine x times 1 minus cosine x, and the 1 minus cosine x, that will cancel. That will just leave us with 1 plus cosine x equaling 1 plus cosine x. So we have verified this identity. For problem number 5, we're going to verify that the quantity cotangent squared theta plus 1 times sine theta equals cosecant theta. We will use one of the Pythagorean identities to help with this problem. Since cosine squared x plus sine squared x equals 1, if we divide every term by sine squared x, the sine squared x will give us a 1 here. Cosine squared x divided by sine squared x is cotangent squared x plus 1 equals, and 1 over sine squared x is cosecant squared x. So our first step will be to substitute for cosecant squared theta. Cosecant squared theta times sine theta equals cosecant theta. Next, I'm going to change cosecant squared theta using the reciprocal identity into 1 over sine squared theta. And I could just keep bringing down the right side. Putting a 1 under sine theta, we can multiply the left side to get sine theta over sine squared theta equals cosecant theta. And one of the sine thetas will cancel, leaving us 1 over sine theta equals cosecant theta. But since 1 over sine is cosecant, we will get cosecant theta equals cosecant theta. So this is how you prove this identity. In this problem, we're going to use a little bit of a trick using conjugates to clear out the denominator. Keep in mind that the conjugate of 1 plus sine theta is 1 minus sine theta. And if you multiply those together, you'll get 1 minus sine squared theta, which is a variation of our Pythagorean identity. So that's where we'll start this problem. Cosine theta over 1 plus sine theta, and we need to multiply by a form of 1, so we're going to multiply by 1 minus sine theta divided by 1 minus sine theta. I'm not going to multiply the numerator out yet. We'll see if something cancels. In the denominator, we get 1 minus sine squared theta. Since cosine squared theta plus sine squared theta equals 1, we can subtract sine squared theta from both sides of the equation to get cosine squared theta equals 1 minus sine squared theta. So we're going to make this substitution next in the denominator. One of these cosine thetas will cancel. That's going to leave us with 1 minus sine theta over cosine theta. Next, we might notice that we have one fraction on the left and we have two different terms on the right. This is what tells us that we might want to break this single fraction into two fractions. So we have 1 over cosine theta minus sine theta over cosine theta. Of course, 1 over cosine theta is a reciprocal identity. That is secant theta. And sine theta over cosine theta, that's a quotient identity that equals tangent theta. So we've proven this identity. I encourage you to try all these problems again and see if you can verify them on your own. Thanks for watching this video. Please subscribe for more math tips.